The first question here asks us to find the exact value of tangent 5 pi over 3, and then it will be easier if we just change 5 pi over 3 into a degree. Right now it's just a radian. So we know that pi is equal to 180 degrees. So 5 pi over 3 is going to be equal to 300 degrees. So we can rewrite this into tangent 300 degrees. And if we look at here, we will know that 300 degrees is going to be right here, which is 60 degrees away from the x-axis. So the alpha angle here is going to be, it's going to be 60. So we can write it here as tangent 60 degree. And we know that tangent 60 degree is equal to root 3. We can write root 3. But before we finish, we have to make sure that there are no minus sign. We're going to look back here. And we know that 300 degree is in the fourth quadrant right here. And in this quadrant, the tangent value is going to be negative. So the answer is actually going to be negative root 3. Now the second question asks us to prove that this identity is equal to 1. The first step I will do is to rewrite cosecant x into 1 over sine x and secant x into 1 over cosine x. And then we will get this. And right here, the fraction here, I can swap places the numerator and the denominator. And then when I do that, I can change the divide sign into a multiplication. And when I do this, I can change this identity into this sin x times sin x. And I will do the same here. And it will become like this, cosine x times cosine x. Now sin x times sin x is equal to sin x squared, and cosine x times cosine x will equal to cosine x squared. And there's a special rule that this particular identity is going to be equal to 1. So the answer is going to be equal to 1. So this is true. The third question here asks us to solve this equation, this one. So the first step that I would do is to change secant x into 1 over cosine x, tangent x into sin x over cosine x, and cotangent x into cosine x over sin x. And then I will move everything to one side, and then I will make every fraction have the same denominator, which is cosine x times sin x. I'm going to times sin x here, times cosine x here, and times sin x here. So the denominator will be equal to each other. And then we will get this. Let's do this part first. Because they are the same denominator already, we can combine it to form this fraction. And we know that sin x plus cosine x will be equal to 1. So we can rewrite it into this. Take this down, and then this also have the same denominator, so we can change this into this fraction. Now to get rid of the denominator here, I'm going to time both sides by cosine x and sin x, and this side too. And so we will get rid of this one, and everything times 0 is going to be 0. So this side will remain 0. And now we will get this equation. Move sin x to the other side, we will get this. And we know that sin x equal to 1, the x will definitely be equal to 90 degrees. But the question asks for the interval of 0 to 2 pi, and this is in radian. So we are going to change the degree here into a radian. So we will get pi over 2. So the final answer is going to be x equal pi over 2. Question number 4 asks us to sketch the graph of this equation. And when we look at it, this 3 here is going to be the axis of the curve, which kind of like the middle of the graph. And if there is a number here, it's going to be the amplitude. And in this case, where there is no number, we will write this as a 1. And when we add the amplitude here with the axis of the curve, we will get the maximum and minimum point of the graph. Now this number here is called period, and it's going to tell us how many times the graph will repeat itself, and in this case it will repeat itself 4 more times. So when we usually plot the graph on the 45 and 90 degree and so on, it's going to happen 4 more times frequently. So it's going to be divided by 4 and we will get this set of number. And this set of number is going to be where we will plot our graph. For example, when we usually have the asymptote at the 90 degree, now it's going to be at 22.5 degree, which is right here and here, and I have drawn the asymptote already. Now let's draw our graph. We have to start with a 3 because 3 is our axis of curve, so right here, and then we move up by our amplitude, so right here, and then we will approach the asymptote. Now this point right here is going to be 1 below the axis of the curve. It's 1 because 1 is the amplitude, so we are going to draw it like this. We are not approaching the x that we mark because the question asks us for the domain until 30 degree, and the x right here is 33.75, so it's going to be before reaching that point. Now let's move backward. So from the 3 here, we will move down 1 because 1 is our amplitude right here, and then approaching the asymptote. And starting over again, we will start at the maximum point, the axis for the curve, and the minimum point. And then we will go further a little bit more because this line right here is just negative 56.25, but the question asks us for negative 60, so it's going to pass this point just a little bit. And then yeah, we have it, our graph. The last question asks us to sketch the graph of this one, and so these numbers here play the same role as the question 4, which is the amplitude, the period, and the axis of the curve. And so we will start drawing our graph. So we know that the axis of the curve is -1. So this is going to be the middle of our graph. And the amplitude is 3. So the maximum and minimum is going to be 3 up and 3 down, which is right here and right here. And when we start drawing our graph, we will go at the maximum, the axis of the curve, the minimum, and then go up to the axis and then the maximum, and then we will repeat this. And as you can see that our graph appeared 2 times and not 1 because we have a period of 2, which means the graph will have appeared 2 times. And on the negative side, we will draw it like the positive one, the maximum axis of the curve, minimum, and so on. But right here we have only one graph because the question asks when we reach pi, not 2 pi, so kind of like a halfway. So we end up with just one graph like this.